Okay, good evening, everyone. So welcome to the Gravity 9 meetup. So my name is Przemek, and alongside Noel, we'll explore microservices architecture. So while microservices will be the primary focus of our presentation today, we'll also delve a little bit into monolithic architecture to provide a nice comparison. So small introduction from us. So my name is Przemek. I joined Gravity 9 in October 2021 and currently work as a lead consultant. And I'm leading a project for the US client from the real estate sector. Noel, maybe a few words from you.
Hi guys, nice to meet you. My name is Noel Adey. I'm the founding partner here at Gravity 9. Just very briefly, Gravity 9 are a software development company. We specialize in modernizing large organizations generally, moving them from on-premise older systems up into the cloud and utilizing specifically AI solutions.
Thanks, Przemek. Yeah, let's continue. Okay, so we'll kick things off by diving into what microservices are and how they compare to monolithic architecture. Next, we'll explore how microservices communicate, covering both synchronous and asynchronous methods. And we'll also discuss where microservices really shine. And to wrap up, we'll summarize the key takeaways and open the floor for your questions. And at the end, we'll be doing a short demo presenting diagram of a project for one of our clients. So it should be really interesting. Okay, so let's get started. So this is our question. So what are the microservices? So microservices are one of the hottest trends in architectural patterns. They are known for their scalability and flexibility. So in a sense, this architecture breaks down a complex application into smaller, self-sufficient units. They can operate independently. So this approach allows each part of the application to be developed, it can be also deployed and scaled separately, making the overall system more robust and adaptable. So in this diagram, let me turn on the laser pointer. So in the diagram, we see a shopping app. So on the left, we have a mobile app and the web app. They serve as the front-end interfaces for users. In the middle, we see the API gateway. So we can think of it like a traffic controller, directing requests from the apps to the correct services. And on the right side, we have different services. There is the account, inventory, and shipping. So each service is like a specialized worker. So the account service manages user information and authentication. The inventory one keeps track of products and stock levels, and the shipping service handles order fulfillment and delivery. What is also important is that very often each service maintains its own database, like a MicroDB approach, allowing it to operate independently without relying for others. So, for instance, the account service uses the account DB, which is separate from the others. So I think this is the essence of microservices, right? Building an application from independent units. So I think we can explore those key features that are listed in the slide to understand why this architecture is so powerful and popular. So the first one is independent deployment. So imagine that we are updating the shipping service without affecting the account or inventory. So this independent deployment allows us to upgrade paths like delivery system. That was about the independent deployment. So we can update the shipping service without affecting the account or inventory. Because if you want to upgrade like a delivery system, you don't have to touch how the user accounts are managed. The second point, loosely coupled. It's about loosely coupled relationships. So we can think of the app as a puzzle with pieces that they fit together, but they aren't glued. So each service can be modified or expanded independently, enhancing flexibility for like easier evolution of the product. And we can also add new pieces to this puzzle without reshaping the existing ones. The maintainability and stability. So this is the third point from this slide. So I would say each service is like a section of a house maintained by its dedicated team. So this ensures that issues can be quickly identified and fixed without involving others. So making the app easier to manage and test. So because if there's a bug in the account service, and we have such a practice in our like current project, so we have multiple teams taking care of the whole microservice architecture, but it doesn't mean that every member of the project knows 20, 30 microservices. Like each subteam, I think, is responsible only for a few of them, which makes it really powerful. And the last one is organized around business capabilities. So we can picture the whole application as a group of superheroes. So each service is like a separate superhero. They all have their unique powers, but only combined together they can do something great. Okay, so let's use the salad analogy. This is, I think, a really nice example to understand microservices architecture. So I was explaining this independent deployment. It was like the first point from the previous slide. So imagine if you want to replace cucumbers with tomatoes within one of our bowls. It's really straightforward, right? We take the bowl with cucumbers, we throw them away, we put inside tomatoes, and that's it. Like this is the independent deployment. The next one is the loosely coupled relationships. So the ingredients, they do not affect each other because they are separate bowls. Then we don't mix them together as one salad. We keep them separate. So this separation ensures that changes in one bowl, it doesn't affect the taste of the whole dish. There is also the point about maintainability and testability. So let's imagine you are adding some new ingredient to the salad. And if an ingredient is spoiled, well then I think we have to throw away a whole salad, right? With separate bowls, this one specific ingredient, it doesn't taste good, but it's only one separate bowl. And also we were sharing this point around business capabilities. So with this architecture, different people, it's like different people in a restaurant, each of them preferring different flavor, right? You can choose their favorite bowl, what they really like. So it's like our users, they're also using separate features of our application. Or for example, we are building the product and there are different persona. There's a UI for customers, there's some back office management. So it's all about those different business capabilities handled by under the hood by different services.
And I suppose depending on the functionality and the feature of that particular service or that sort of realm of responsibility for that service, you might choose a different technology in those, or a different database technology to support that. So whether it's sort of high throughput or super complex logic or sort of payments sort of implementation, might use a different approach.
I think artificial intelligence, for example, you can have whole setup in .NET, but you can have dedicated service in Python. It's very powerful for it. Okay, so this is a very interesting example from the Microsoft documentation regarding microservices. We can quickly understand on a technical level how it looks. So on the left side, there is a small area dedicated to the user interface, which includes a mobile app, a single page web application, and a traditional web app. So these are the parts that end user directly interacts with. And now we can take a look at the backend on the right. So here we can see the real power of this architecture. So each service is color coded, right? Like Microservice 1, the blue color, Microservice 2 with the green color, and Microservice 3 with the red color. So they handle different parts of the application's functionality. So instead of relying on one large monolithic system that manages all product features, like it's split under the hood. So for the end user, like, it looks the same, right? But you see how complex can be under the hood, and also like this independence of services, it allows system to be in more easy way updated, right? We don't have to risk like with the monolith when you like, for example, you introduce small fix, but you deploy it as a whole. You can like cause complete outage of the whole application, right? Microservices, it's easier. Okay, so microservices, are they the ultimate solution? Is every project perfect for microservices? I think not. What do you think about it?
Yeah, it's interesting. I suppose once you know it, it's difficult not to do it as an engineer because you know the benefits. But it does come with its challenges. It's quite complex. Like if you break your entire organization down into a bunch of microservices, maybe you end up with 50 to 100 microservices that represent all different things. That's actually quite challenging to own. Depending on your situation, I suppose that's what you weigh up. The difference between those complexities.
Yeah, I think it would be really hard for us to answer this question, like say microservices or monolith. So maybe let's try to understand what this monolith is about. Let's take a look. So once again, the salad analogy, right? So we saw earlier that microservices, they were like individual balls with separate ingredients. So a monolith is like a salad. Everything is mixed together. It's intertwined, right? So you can easily say that any ingredient is independent. They all compose one dish, right? So any change to an ingredient impacts the flavor of the salad. You add more salt, you add the cheese, and so you affect whole system. So similarly, in monolithic application, like changing one part influences, like it may influence all the features, even in like very negative way if something goes wrong. Okay, so I think as we delve into the technical details, let's explore how monolithic architecture differs from microservices, focusing on the key points and referring to the image on the slide. So the first point is about the single system deployment, right? The first point. So unlike microservices, which are smaller independent services, a monolith is single. It's a single unified system. So any new feature or update, even a small one, requires redeployment of the entire system. So, for example, like even a minor bug fix, like it's still redeploying the whole application. The second point, integrated components, right? So in monolith, the product is deployed as a single component. And this single component, it has to integrate all subdomains and business operations of the application, tightly coupling them together. Like with microservices, for example, you could start working on some, separate feature, even start trying to introduce AI, like separately. But in monolith, typical monolith, like it would be challenging because suddenly in like code base, start getting some AI proof of concept, right? So I think like even in this image, this is example image, but we see different functionalities like billing, storm management, notification. They are all part of one system. Also, the single component operation. So this is the third point. So monoliths manage all system components as unified entity. So initially, this simplifies control because we have one system, one big application, but especially scaling, right? This is very important. And scaling and updating parts independently, it becomes challenging. Of course, like everything is within the monolith, so all operations are local operations, so there are not like any latency risks that are like in microservices when they communicate together. So this is like the main characteristic. It brings some advantages, but also disadvantages.
Yeah, I guess it's sort of more complex in one element in that it's tied together and sort of unintentionally like complex. Whereas the microservices architecture is simpler on its own, but actually quite complex. And to your point, requests out to one microservice to execute something outside of its domain, that's actually a slower operation than just calling in code to something. So certainly pros and cons.
Yeah, that's true. Sometimes you might have 1, 2, 3 services under the hood, but sometimes there are hundreds of services. Like I think very big players on the market. If you think about Netflix, those are like plenty of them. And to finish, like a characteristic of the monolith, centralized data management. So this is a very historical approach because those systems often used a centralized data management approach, simplifying data handling, and also it limits flexibility. So I also in my career, I worked on different monolith projects where under the hood there was only one database, one database system. So compared to microservices, where we can have different microDB per different subdomains.
In my experience is also that logic tends to find its way to the bottom in a monolith. So you end up with lots of logic on the database, store procedures, those sorts of things, because you can't share that logic higher up because you sort of building it, duplicating logic quite often around.
Yeah, obviously you improve performance in this way, but still, if you think about the modern architecture, it's not something that probably we don't want to follow this if it's not needed, obviously. Okay, so while the monolith might not sound as fancy as microservices, it offers several advantages. We can quickly take a look at them. Those are 6 points on the slide. So the first one is unified code base. So everything is contained within a single system, right? So having all code in one place, it simplifies management at the first glance. So it's like a big house where all rooms and belongings are under one roof. So definitely, it's somewhere there. It's somewhere in this house. It must be there. The second one is the simplified communication. This is what just Noel mentioned. So this communication is straightforward. You don't have to think about services communicating together. We eliminate the complexity of inter-service communication. We reduce latency, right? We simplify interactions. So I would say it's like preparing food in a restaurant. Let's imagine you have one kitchen and they prepare everything, versus you might have different kitchens, even on different floors. In one kitchen, they collect ingredients. The second kitchen, they cut ingredients. The third one, they cook everything, and the fourth one, they serve. Okay, so also the collaborative development and simplified deployment. This is point number 3. So monolithic architecture allows multiple developers to work together easily on the same system. So new team members joining, they only need to understand at the beginning one code base, which speeds up onboarding. It's simpler. Even when I was joining my current project, when I was joining Gravity 9, right? So obviously when I took a look, at the whole architecture, the high-level perspective, I was like, wow, it might take a while, but at the beginning, thanks to organizing our teams, working as a work teams, it's easier because I had to only understand one microservice, one API, microfrontend, and that's all. And I was onboarded. So, but still, if you take a look at the big picture, I think jumping into monolith is faster.
It's when you're in your environment and you're building something and you're relying on 3 other components that you don't own, whereas in code base and you've got to request out to them, that's some of the complexity there, isn't it? And the time it takes to set those things up or replicate them or replicate that environment in its distributed fashion is much harder, isn't it?
Yeah. And especially for clients, time is money, right?
Yeah.
Okay, the delayed decision making. So the point number 4, so with a monolith, you don't have to make complex architectural decisions up front. The simple setup of the monolith allows for quick starts. It is ideal for the new products. We often have clients that they have some vision, right? But in the end, what they want is they want a quick upgrade. I think this is also the mission of Gravity 9, right? to provide some solution to our clients. But we are not saying that like for every the microservice is the best one, because I would say it's like you're packing your car for an extreme off-road adventure. You can pack your Land Rover, like you can prepare for it, but in the end, there's like this project would be like driving from the city center of Birmingham to the outskirts of the city. Okay, so let's move on to the fifth point, the simplified testing. So the point number 5. So testing in a monolithic system is relatively simple because you are testing a single component, right? And in microservices, testing can become much more complex because you don't have to, you write unit tests, but also you need to take care of the integration tests to double check. For example, like if changing one service, the contract of the service, if the second service is still able to communicate with it. And like we also do it in our current project. It's a different set of different tests that you don't need so many tests in Monolith to confirm like everything as a whole unit works correctly, right? So it's like a teacher grading like students with one exam versus grading students with multiple exams where they are like connected. Some of exams have prerequisites like you cannot pass the physics exams if you won't pass the math exam. And the easier debugging. So yeah, this is very important, especially for new joiners, because we also have to think about architecture in terms of people that work like on the project, because sometimes like not every project you have senior developers, all the senior developers all around. Sometimes you have only one senior developer and the rest are like some junior developers. So especially debugging, right? So debugging the monolithic architecture is simplified because like all logs, all error logs, they are like consolidated in one place. And unlike microservices, where each service generates its own logs, but then like you have to connect them together, right? So to understand if the request is failing, and I have 3 microservices saving some logs, to understand that it's all about one operation, right? So it's like investigating a single crime scene where all evidence are within one place versus having multiple crime scenes and trying to connect dots together if this is still the same crime in different places, or maybe those are multiple crimes. So these advantages from the slide, they show why a monolithic architecture can still be a powerful and practical choice, especially for projects that do not require complexity and scalability offered by microservices. Okay, so we have explored both monolithic and microservices architecture. So you might be wondering, should we start our project with a monolith? Because there are significant benefits, as we discussed. So we have the benefit of quick development and deployment. So we can build and deploy a product relatively quickly with a single team, delivering it to the client faster. And also we have ease of testing and debugging. We don't have to take care of any integration tests. Debugging of the system is easier. So we have a lot of benefits. So we will ever need to work on microservices. And if so, when it's the right time to consider transitioning to them. So I think the decision to migrate from a monolithic architecture to microservices is highly context dependent. It depends. I think it's the best answer in IT. So it's crucial to evaluate the pros and cons based on your product and the product's requirements. So let's take a look at some key challenges that may signal the need for microservices. So the first one is the team collaboration difficulties. So as application grows, team members might interfere with each other's work. It's like you have 3 people on a project, and then client will tell you, okay, we give you 3 more people, and then you will deliver 2 times faster. So unfortunately, it doesn't work in this case. And when the team will be working on one big code base, it will you can add, 10 more developers, but I know your performance will be, your delivery will be not so higher, right?
Yep.
Yeah. The deployment challenges, the second point. So in monoliths, deploying any new features requires updating the entire product. And the microservices, as we discussed earlier, they allow updates per component, leading us to smaller, safer releases. The third point that we have in the slide, we have scaling difficulties. So microservices, they let you scale the high traffic parts of the system, and thanks to that, we can optimize the resources. And with the monolith, obviously, we have to scale the entire application, which can be inefficient, right? Because, for example, like we would like to scale like only, the payment system, or there's some event like this Euro 2024 tournament. People started buying tickets, so we wanted, to scale only this tickets part of the system. But with a monolith, we have like one set, one big code base, right? One product deployed to our infrastructure. Easier modernization, we are now at point number 4. So updating independent services is easier and less risky than overheating the entire system. So the microservices allow for more gradual modernization, reducing overall system disruption. And we have the fault isolation. So this is the last point from the slide. So failures in microservices, they are contained within the affected service, preserving the rest of the application. And in monoliths, a single failure then can lead to a complete system outage. So those points illustrate why transitioning to microservices can be beneficial, especially as your application grows. On the slide, we can quickly visualize side-by-side comparisons of a monolith architecture and microservices. So on the left of both images, you see monolithic architecture as a single unified system, everything tightly coupled together. And on the right, we see how the same system might look after transitioning to microservices architecture. So here the application is broken down into smaller independent services, each handling a specific functionality. Okay, so we have decided to go with microservices, but how to start implementing them? So whenever we are building them from scratch, or we are doing some migration from a monolith architecture, we need to design wisely and strategically. So embarking on the journey of microservices is not a one-size-fits-all solution. So every business case is unique. Each company is different. We have different people working on the project. They have different experience, different skills. So I think this one that I'm presenting on the slide is called the strangler pattern. And here are some key characteristics of the strangler pattern. So the first one, identify services. So try to determine the distinct services that make up the system. Each service responsible for a specific piece of business functionality of the business domain. And define their responsibilities. So clearly outline what each service is responsible for, what it should do. We should also design APIs. So create well-defined APIs for each service, specifying how they will communicate with each other and with external systems. Deploy and host microservices separately. So try to plan for separate deployment and hosting of each microservice to ensure they can be independently scaled and managed. And of course, invest in observability. So set up good monitoring and logging for each service to track performance and troubleshoot issues. So you will be able, to connect logs from different services. They are about the same operation.
Yep.
So migration, in terms of strangler pattern, is the gradual process. You start extracting independent modules and transforming them into standalone services. Over time, as illustrated in the slide, the monolith shrinks while the network of the microservices grows, reflecting a progressive approach.
Just, I suppose, to call out one of the approaches we use to help identify and define the scope of each microservice is something called domain-driven design. So we look at an organization, we break it down into its sort of sub-parts of its, what it looks like. So it might be payments or sales, and sort of break that down from a logical perspective, and then use that then to hone in onto what are called bounded contexts, which represent microservices. So what we're trying to do is reflect your business in technology, and that's the whole point. And so microservices, I think, comes out of, historically have come out of that sort of way of thinking and breaking down your organization and defining these small elements of functionality that represent your business behavior.
Yeah. Okay, so now let's take a moment to briefly discuss a crucial aspect of microservices architecture, the communication between services. So imagine ordering food at the drive-thru restaurant. So when you place your order, you wait at a window when somebody returns with your meal. So in software, this is how synchronous communication, it works similarly. So protocols like HTTP or gRPC, a client sends a request to a service and waits for a response. So this is just like a drive-through. The client code blocks the execution thread, waiting for the response when the information is returned from the server. So this method ensures that the client receives the synchronous one, complete and timely response before proceeding with other tasks. So common example of service-to-service communication is using REST API synchronous manner. So here the client sends a request via HTTP and waits for the server's response. And within a microservice architecture under the hood, like service receiving the request processes it, often calling other services or accessing like databases. And after processing it, it constructs a response and sends it back to a client. And meanwhile, the client, this is like web browser, right? It continues performing its tasks until it gets the server's response. So generally, HTTP protocols and the rest are the go-to approaches for designing APIs, particularly when exposing API interface outside of microservice cluster. So this ensures that different services can communicate together. They can communicate effectively and reliably, hidden behind a dedicated service. Like in this architecture could be like API gateway, right? And they are hidden behind gateway. Okay, and asynchronous communication. So while the synchronous communication...
Sorry, just had a point there. Just on the synchronous side of things, I mean, there is a kind of an anti-pattern leading into asynchronous communication, in that we don't want too much synchronous communication between our services, because we end up with effectively what's called a distributed monolith, which means I've got 10 microservices. They're all independent, but actually they're all sort of temporally dependent on each other. And so you end up with lots of separate components, but actually I still need that one to be alive for this one to work. And so that's why we prefer more of an asynchronous approach, where this microservice lives independently. It doesn't know about anything else. It doesn't depend on anything over here, but it can send messages and send and receive those messages, so that even if that thing isn't alive now, it can get the message and respond back potentially if there's something needed back to that initiating microservice. So sorry, just to call out that the reason why we'd want to use, because asynchronous is much more complex, which is what Przemek's going to go into here. But
but I think it's also a good example with the synchronous, what you mentioned, that then like, for example, you have like 3 services, but they are like spaghetti. Service A talking to service B, service B talking to service C, and then like you try to independently upgrade service B, but services A and C communicate that, but they are so A and C like they are somehow affected, right? Maybe we're only like upgrading the service B, but the other services, okay, they will be working like this. The components is still alive, right? But like if any operation going through those services requires communication with the service B, then like all 3 services are affected. So that's why we have the asynchronous communication. So unlike the synchronous one, the services, they do not interact directly. So instead they send messages to a message broker, which other services listen to. So in the setup, the service doesn't need to know about other services because it doesn't call the API methods directly. it only needs to send a message to the message broker, and after sending the message, any service can react to it by performing specific actions in response to the received message. So here's like, in this diagram, it's very simple, but yeah, so one service like sends a message without waiting for a response, because I sent a message and okay, I don't care, like it was sent. And then like we have like subscribers, like different components that can consume the message asynchronously, meaning like they continue their tasks, like they take care about the message that was sent. So, and we see that the execution thread it's not blocked as it's for the synchronous communication. Like services react to events or results instead of waiting for them. So this approach is similar to sending an email. So you finish writing your message and you press the send button, but you don't sit at the desk and like doing nothing, just waiting for a response. Like
some people say,
yeah, maybe it's super important for you that you could do it, but yeah. So yeah, that's the difference. Like it will be when it will be, right?
Yeah.
And maybe for the asynchronous communication, like we can mention that it can be implemented in two modes. It's called one-to-one mode and one-to-many. So in one-to-one mode, it's called queue. There is a single producer and a single consumer of the messages. So this setup is straightforward, where each message is processed by one receiver. In one-to-many mode, we have multiple consumers, subscribers, like here, like in this part of the slide, as each message can be handled by 0, 1, or many recipients. So this allows for greater flexibility and scalability in processing messages. And what's also very important is that asynchronous communication, it uses like a message broker, like for the scaling, right? Like we want to easily, add new, requirements. So for example, like there's some order submitted, right? And there's like SMS notification, but we want to add maybe email notification or some other notification, or even some promo codes generation. So like this is flexible, like with the asynchronous, just I add another subscriber with like actual implementation.
Yep. I suppose just to add to that, the whole premise of sort of asynchronous is based on effectively a pattern really around promise. So there's a pattern called eventual consistency, which means once I publish a message from my microservice, I can guarantee and assume that will be delivered. And that's key to the whole event-driven architecture, in that you have to trust that if you get that message on the service bus, it gets to its destination and will be processed appropriately. It won't be dropped. And I suppose that needs to be built into the protocols and the applications that built for these solutions. And I suppose just, on the other side, a queue is more designed for a loading scenario. So you would have a queue where I might want to distribute I might have 3 versions of one microservice that are sort of sharing the load of messages coming in when there's lots of messages. So I don't know, an example would be process payments if there's lots of payments.
Yeah.
Whereas a topic is good in the scenario where we have, it's good for expansion, as you were talking through. So I can raise an event to say, inform the client, a customer of some information, and you'll have an email, text, and a sort of some other communication mechanism sitting on the end of those, and we can expand that over time and not affect the producing microservices. Where you go. So,
and this is like an entry point for the event-driven architecture to understanding asynchronous communication. Like different article says that it's also like living together with the event-driven architecture, where everything like relies on this kind of approach. The flexible interactions.
And that kind of lends itself. We're a modernization company. We build lots of new functionality and components around existing legacy systems, and building events that either come from or go to microservices and then into those legacies via something called an adapter, which we would listen to events on behalf of that system. It gives us the flexibility then to remove those legacy systems over time without affecting your new architecture. So it's a strategic pattern as much as it is a sort of a comms and resilience.
Okay, So now that we have covered some of the technical details, it's time to look at the use cases for this kind of architecture. So let me quickly go through it. So the media content, right? So streaming giants like Netflix, they manage billions of API requests daily across the globe. And it uses various microservices under the hood to manage different functions: authentication, user profile management, content recommendation, billing, content metadata services, and like other like services it offers. So for instance, when a user searches for a movie, multiple microservices collaborate under the hood to provide recommendations for the user, provide metadata of the movie, and in the end facilitate the streaming process for like content delivery network, right? So microservices, they like, I think many examples about scaling. So they can scale individual services independently, allowing them to handle the massive and growing user demand. Because when I was reading the story in the Netflix, like, there were like 2 billion, I think, requests on a daily basis in 2015, and right now it's just, a few hundred billions, so interactions on daily basis. So you can see how massive, how this architecture in terms of flexibility was important for them.
Yeah.
Because they also they started with the monolith architecture.
And not everything is under that scale as well. I think that's the point, isn't it? Because your account management microservice in that scenario might be 3,000 interactions a day, but your streaming click review or thumbprint microservices might be serving hundreds of thousands per second. So they're very, very different traffic demands on each of those, and that's another reason why you might want to just have a very small functionality that's highly scalable, whereas not everything else, because then there's an expense consideration. So
it was like with these balls, for example, like there are 10 balls, but then you can replace one ball with the mega ball.
Right. Yeah.
And it was easier. Okay. I think also data processing and big data, it's something very similar. So there are each microservice can be responsible for a specific task within the data workflow. For example, one microservice might collect data from various resources, where other microservices are responsible to identify some trends, some patterns, this is how financial institution works. So this modular approach allows microservices to be independently scaled. This independence, to manage fluctuations in data volume, right? So, for instance, a spike in data from financial markets can be handled by dynamically scaling the relevant microservices, providing up-to-date insights, and still making sure that the whole system provides real-time, decision making. Yeah. Okay. This example is really nice. I think it's the most basic one, the easiest way to understand it. Let's imagine we have a large e-commerce platform based on a monolithic application. So updating such a system in one go poses significant risks, including the risk of extended downtime, which will be expensive for us, running such a platform. So with microservices, organizations can decide to adopt a phased migration approach. So instead of massive overhaul, they can gradually separate and modernize different business areas. So they might begin with user interface, then some payment system changes, then later address some inventory management, other stuff, service by service. So transforming those functions into microservices, it allows for targeted updates and improvements without the risk of bringing down the entire system. Okay, and the last example, let's consider an online banking platform. The security and the reliability of transactions is crucial. So in microservices architecture, critical functionalities like payment, they can be encapsulated within their own dedicated microservice. So this separation means that if there is a system failure or need of modifications, the core transaction functionality remains secure and stable, like preserving several consequences. And also like those isolating services, like it was, the good example is like I was reading recently article like Black Friday, right? It's a crazy time.
Yep.
So when you have independent services, you can independently scale them. You can handle like such events like Black Friday or the end of financial year. Okay, and as a summary, I would like to summarize the advantages and disadvantages of microservices. So quickly going point by point, without going into details because we have covered everything like during the presentation. So the improved scalability. So microservices allow precise scaling of individual components based on specific needs, ensuring efficient resource use where it's needed most. Independent deployment. So each microservice can be deployed separately, enabling faster updates and reducing the risk of disruptions across the system. We have also diverse teams and technologies, so different teams can manage specific services using the best technologies for their task, enhancing collaboration and innovation. And as Noel mentioned, like they can like incorporate using Python for AI in their services. Enhanced resilience, it's like point number 4. So since services operate independently, the system remains functional. Even if one service fails, unlike in a monolithic system where one error can affect the entire application. And the last point is the clear system boundaries. So defined boundaries, it simplifies incremental updates and modifications, making it easier to manage and evolve the system over time. And of course, like not only the benefits, microservices architecture, they present several challenges. I'm saying challenges because not everything is disadvantaged. So everything we can deal with, but we have to think wisely about it. So the performance challenges, obviously, network latency and inter-service communication can impact performance, but it doesn't mean this is super harmful for the microservice because then nobody would be using them. But still, we have to consider them in terms of our process and requirements we have. The complex testing, so we mentioned the individual unit tests, but also integration tests. So this increases the complexity and the duration of testing process. We mentioned this distributed logging and the single crime scene versus multiple crimes. So managing logs from multiple services can be challenging. So it requires some effective structuring and organization to identify issues. I think we have right now yet the point number 4, the transaction management. So handling transactions across multiple services and databases is complex, with a risk of data inconsistency if failure occurs mid-process. So it was like you mentioned earlier, the synchronous communication. It's a service it's performing one operations, doing some save operation, but before doing save operation in its own MicroDB, it performs save operation in other service MicroDB, and the one microservice will commit the transaction to the database, but the other one will fail and have inconsistency.
Yeah, and I think that's completely different. I think when you move into a microservice environment, you have to think very differently about transactions because distributed transactions are next to impossible. You effectively can't implement them across. Well, you can put patterns in, but they're very expensive to implement. So you have to think of how to decompose your solutions in a way that makes sort of complements an event-driven asynchronous world. It's not a matter of this component calling this one in memory because that's in memory. If it's out of memory, there's always potential this thing's not going to work, or it's asynchronous and you're not going to get the response back. So I think that's one of the biggest changes in understanding how microservices work in an enterprise. Is actually how do you manage what used to be a transaction from this module to that one? That's very difficult.
Yeah, that's true. And the deployment effort. So this is challenge, but in the end it will be advantage because obviously at the beginning we have to set up the deployment process for microservices. we release different services, like there are like different components like deployed like to Kubernetes cluster or stuff like this. So obviously at the beginning, it's more complex. It looks more complex. So we have to invest more time and money. So understanding the challenges is crucial for making informed decisions about adopting microservices or choosing a monolithic approach for your application. Okay, so and we at Gravity 9, we also rely on microservice architecture in several projects. So yeah, I think it's a demo time. So we'll share the story of one of our clients who embarked on a journey to microservice architecture. And I think in the case study, we'll highlight not only the technical benefits they achieve, but also the positive impact on their organizational structure. Mm-hmm. So yeah, so we can close the presentation. And yeah, so maybe at the beginning I was thinking, no, that maybe because I think you would be like a better person to explain it, like how it started with our client. So you remember how the client's architecture looked? I think it started in 2020, right? And their architecture at that time and the challenges they were dealing with was much different.
Yeah, so we started working with a large US-based property company. They had two quite big solutions when we started working with them. So a version of a CRM system and a quite well-known big property management system. And I think it was a good example of uncontrolled and unplanned complexity. So the company had grown extremely quickly, and which was massively successful and still is. But as a result, their IT and their capability technically was lagging behind that growth. And as a result, these two systems that represented two sort of fairly big areas of responsibility just grew exponentially. And within those, the complexity was immense. So within the CRM, there was lots of rules and duplication of rules and plugins on top of plugins, and then the same in their sort of property management system. And then those two things had to talk to each other. So there's like bi-directional information going to and fro. It made it quite difficult for them to innovate because they couldn't move. So being able to make a change in one system, it had to be reflected in the other system. But then there's also this sort of buried in complexity logic in each of the systems. And so we've, over the past few years, been helping them untangle that effectively and build out a nice, clean set of responsive microservices with clear responsibilities, using event-driven architecture as the sort of backbone, and then building adapters into those existing systems so that we can build our new world, build a new digital experience for their customers and their clients, while maintaining their legacy systems, but over time slowly eroding those systems and bringing the functionality that was in those into the new world of the microservice architecture. So quite a big program, lots of complexity that's been distilled and pulled out. But I think this approach, we've never felt, I don't feel like we've ever felt like we've been in a corner with these patterns. So we use domain-driven design to understand the sort of the layout of the business and the responsibilities of the components. We break that down into microservices that represent the functionality and the implementation. They've got their own databases, so it's much more scalable from a data perspective. We've also employed not only microservices, but micro front end.
Yeah, we can even take a look at the diagram, right? So starting from the bottom of the mirror board. So obviously we have our clients because we have also mobile layout for our pages. So it's not only for the web browser, it's also mobile browser, right? And then here we have the micro front end architecture. Sitting behind the Azure front door, right? And what is also important, because I think at the beginning they only had the customer UI, but with their new ideas and requirements, they wanted to have different persona, accessing applications. So we not only have, for example, here we have the customer UI application for customers, but also having application for their employees, some back office management, and so thanks to micro frontends, we can easily serve different persona, and if they would add more persona, it also would be important. And I think if we go higher, in the diagram it will be higher, but like it will be like bottom of the architecture. From the microservice perspective, like we use this backend for frontend approach, right? So each micro frontend it communicates with appropriate API, and actually this API it doesn't contain any special business logic. It's like a proxy that directing requests and the communication to proper set of microservices, which are hidden behind the API, Azure API management. Yeah. I think the Azure API management is also like very nice pattern, like the security.
It's a good perimeter security. It gives you a lot of control over, the requests coming in. We can throttle things. We can even open up accounts for partners and give them access to certain functionality under certain rules and restrictions. So it's quite a powerful pattern there. And actually, we've done a couple of sessions on API Gateway, so we'll maybe open the notes and add a link to that. But the other thing actually that we've built internally at Gravity is a product called Orbit, which is designed specifically to manage some of the complexity. So you look at a microservice architecture, it's actually quite often overwhelming. So the simplicity and the effectiveness comes from the fact that you've got a small piece of functionality that you're maintaining. But actually, when you look at it as a whole, and we mentioned this earlier, if you've got 50 microservices, that means 50 databases, 50 potentially front ends and applications that sit on. That's a lot to own and manage. So we've built an Architecture 360 type product that allows you to see all of that and apply rules and aggregate information and show dependencies, which is some of the challenges that you get from sort of owning these large number of components that sit out there independently.
And also, like, if we take a look, like here we have like set of our services, like to make it simpler, we only show a few of the services, right? And you mentioned those like property management systems here as like third-party integrations. And I think also like we have pretty nice solution, like because we are like communicating with external systems, like with like Azure functions, like you could use logic apps, but also like I think most of it is like about Azure functions. And it's also like very important because like I would say it's anti-pattern to have your services and some logic within your service and the models defined only to meet the needs, the contract of the third-party system. Right. Like for example, like your microservice communicates with a third-party provider for some soft credit checks, right? And there are like plenty of the providers in the market. Each of them have different contract, different model. So, for example, you work on implementation for like one of the provider, like so you keep this code in your solution, right? In your microservice, like, and then one day it turns out, okay, I have to exchange with something else. So with those independent adapters, like the Azure function, this is like this asynchronous communication. So instead of polluting your domain, like breaking those DDD rules and like merging the models together, making like everything strongly coupled, then like you based on the events, for example, like some events happening in the third-party system, and by using Azure functions that consume those events, and they can like publish events that we consume. So we represent the changes, and you can also work in the other way around.
That was one of the main benefits, really, is building a canonical, effectively a canonical environment where the microservices will talk to each other through contracts and events, and their external sort of HTTP endpoint web service contracts, and that allows you then to insulate against any external products. So you're not sort of bound to a product as you were talking through then. So it could be a payment provider, or it could be a property management system, or a CRM, or whatever it is. You're not tied to that. Your modern architecture sits in isolation and communicates through clearly defined contracts, which could be events or service requests. And that means we can effectively build a plugging enterprise architecture. So we can take this product in, take that one out, and it doesn't affect the core platform, which is key to the success.
That's true. And I think it's also worth to mention that it's not only the technical perspective, the microservices, but it works with people, right? Because like technical aspects aside, but like considering like multiple like web application tools, micro frontends for the customer, for the employees, different persona, many APIs under the hood, like each one API per each micro frontend. It could be dozen of services, different integrations. Like thanks to that, we can like split people working on the project into like several smaller work streams.
Yep.
So thanks to that, we have multiple benefits. Like teams are smaller, easier to manage, because like it would be impossible, for a team lead manage a single team of 20 developers.
Yeah.
But they are split also, like they do have different responsibilities. They own different part of the application. Like you have, each of them have their own piece of cake, right? And people, they do not interrupt each other. So yeah, I think it's also really nice.
Well, it doesn't come without its complexities, and I think that's something you touched on earlier. Is that the growth components, and nobody wants to manually deploy 6 microservices part of a change. So a big muscle that you have to develop and sort of embrace is DevOps, and I know we've been talking about that in recent talks. But automation of this stuff, going out and being able to auto deploy and auto create and update, that's majorly important and becomes much more important in a microservice environment.
Yeah. Okay, so I think we have also covered this quick demo presentation of the architecture, right? So generally summarizing, I think, in my opinion, like I'm also curious what you think about it, is that because we tend to practice both at Gravity 9. So, and we have quite a lot of projects with Monolith, because Monolith approach make sense in the short term, where like when the project is smaller, the requirements are not fully defined, then very often we can split the project into phases, right? But obviously, like at some point they might appear like some challenges saying, start moving towards microservices. So we also tend to, practice the modular monolith approach, which is like something in between. So generally, we don't have like one answer which is better. In the end, I would say it depends. So start using the monolith when you don't have to go with microservices. When you start the project and say, I will go with microservices, but they are fancy. However, your requirements doesn't indicate you will need it, then what's the point of doing it?
Yeah, I think it's dependent on your circumstances. I think if you're embarking on an enterprise engagement, or a good example is AI at the moment. Like having companies adopt AI. I think you want to adopt it in isolation. One, things change. 2, it's difficult to sort of integrate that into a monolithic environment. So I think microservices is a good choice when you're wanting to modernize, but you've got a legacy that you need to work with. And so rather than building another monolith, sort of build these satellite pieces of really high value functionality on the side of your products. I think that's where they shine. And certainly in most recent times, that's where we're seeing kind of demand and interest is, okay, we want to build this small thing. We can't boil our ocean at the moment. We want to introduce AI into this flow. Well, then microservices and event-driven architecture are perfect, because we can build an adapter from their old system, throw events out, and have the intelligence isolated in a microservice that doesn't affect the rest of the world. And so we can isolate complexity, and that's kind of key to some of the new engagements we're working in. But yeah, if you've got a small application and you don't need to, I think good decomposition of it in any component is like makes sense. So if you've got an application, break it down into modules, and maybe even put some contracts in the code that would allow you to tease something out as a service later on. So always have a roadmap, I suppose, if it's a strategic product. If you're going to throw it away in 2 months, then maybe don't bother. But yeah.
But it also, plan strategically and wisely.
Yeah.
Okay, so I think that's all that we have for today. So thank you very much. I don't know if there are like any questions from our audience.
It was an extremely clear presentation with thank you as a non-technical person. I think I understood 95% of it.
Oh wow, that's very
more than I thought. And towards the end, you answered pretty much every question, i.e. you had to stay down, but honestly didn't answer that. When would you really all. What examples do you have of when you would recommend a monolithic architecture?
Okay, so what would be the example? So I'm thinking about our project in our company. So from my experience, because like in Gravity 9, from the beginning I work with Microservices Architecture, but like I often like worked on a project that like lasted 3 months, no longer. And so to deliver something to the market. So with microservices, like it needs time to work out like deployment, the proper architecture. So those preparation, like it may take like even few weeks, right? Understanding it. And with the monolith, like people like several people like in the company, they could be on a bench and some client comes and say, I would like to have some, prototype, right? POC. I know those are like minimal requirements on a piece of paper. So let's jump quickly into it. And yeah, monolith is the only choice that.
Makes sense. But be aware that MVPs never go away or POCs that sort of stick around. So there's always that element of think about it in the code.
Yeah,
that is a good example of a POC. Like, let's try this out. We've got a business initiative. It could be a product at a bank, or it could be a whatever, an insurance product, and then building something and just throwing it in there and having it as one is much easier, and you do save. Unless it's just one very small piece of functionality and it is a microservice, then build that and put it out. But yeah, it does depend, but that's a good example, yeah.
And if you do that, are you able to design it in a way where it's easy to adapt it into micros?
Yes. Yes. Yeah, so there's like specific like implementation of a monolith. It's called modular monolith. So like if you take a look at the architecture, so it's still one piece of like it's one block, like a monolith. But then like the way it's implemented, like the communication between functionalities. So you can have like 4 like major functionalities, and they are kinda separated. So they are intertwined. It's not like spaghetti that all of them like are glued together and you cannot like separate them. So yeah.
And you can build, in the code patterns, even if you're building a monolithic application, you can effectively modularize and put something called interfaces in, so that you're talking to an interface, and how that's implemented on the back end of that, even though it's in memory, it's the same application. Could today be in memory, but then you could build a proxy and call out to something later on. So there's patterns you can employ, even if you're building a monolith, that can help you go, okay, this was a monolith, but we're now going to sort of tease it apart and distribute it. Then some things can help in that respect,
Yeah, I also have some diagrams of the modular monolith, but the thing is that this is like, we have the architecture practice series in the company, and we like present different patterns. And I know there will be like the next presentation, next meetups, and there will be also a modular monolith. So maybe I don't want to do a spoiler here. So you have to be patient to see more about the modular monolith. But yeah, answering your question, that could be the solution. Yeah.
How do you think using AI will affect how you're able to create the microservice architecture? Is it going to speed it up?
I've got some thoughts here, but feel free.
You've got your thoughts. Yeah, so this is interesting, like, because generally, like, obviously is a powerful tool, right? So something that AI offers today, like in 1 year, it could be like totally different. So I think when I'm playing like with AI, for example, like a lot of people use ChatGPT. So right now I'm focused like on the daily work of developers, of the architects. So yeah, obviously it can give you some hints and ideas. I'm not sure if it's still like very powerful, of replacing architects, because you have to like show what you have in mind. So for the architecture, in my opinion, not yet. But for example, like implementing those services and each of the microservices implemented in domain-driven design fashion. So yeah, there like in terms of implementation, so there's like a good implementation. We follow good practices. So yeah, as the such a tool like, I don't know, ChatGPT, like developers, they can like, they have some example like, okay, I see the pattern and I'm writing the code, so I need your help, like, because like still like some people that are learning new technologies, now I see tendency that they start using ChatGPT for learning. If it's good or bad, I don't want to know to judge it, because some of people think that it gives them benefits, they can learn, but obviously they cannot like forget that they have to learn on their own. They cannot do like copy paste from the ChatGPT, but they can like support them. They can preserve good practices in terms of implementing such a single service. But for the architecture, for the high level, like architects obviously could consult some solution, but for now it's not something they need to have. It's like nice to have.
Yeah, I think it's sort of moving, but there's definitely efficiencies to be had today when you're writing the code, like because it is well defined as well. It's easier actually to build things in an automated way. So we use domain-driven design that has a certain number of patterns, aggregate roots and entities and those things. So you can almost instruct an AI agent to build code. It does take out some time, but I think to your point, I think there's a lot of effort put into the analysis and understanding of what a problem is before you get to the code generation. So not taking anything away from programmers, but like the hard part actually is kind of upstream. It's working out how you want your solution to look and how you decompose your services and your events into an architecture. Now, there will be tools that will come to help with that, but I think the current efficiencies are in code gen and test generation, like unit test generation. That's very useful, like being able to jump on Copilot and generate your own unit tests and have full coverage. That's super useful. But it's a moving target, and it's definitely helping already. And I'm sure there'll be more in the future. But yeah, it's a changing world, isn't it?
Yeah, that's true.
Yeah.
Thank you.
That's all right. Thank you for those. That's good. Awesome.
Thank you.